Paper 1, question 6. It's asking us, firstly in part A, to just do an integral. So it's asking for the integral of e to the sine x cos x. So we'll do it formally. Some of you might just be able to spot how to do it. But what we would do is we would say, let's let u equal the ugly bit, which is e to the sine x, and the ugly bit of that is the sine x. The reason we do that is then we get du dx to equal cos x. The derivative of sine x is cos x. So we can say that dx, if we rearrange that, dx is equal to du on cos x. Bring the dx up, the cos x down, treat it like a fraction. It's not really what's going on. So we've got the integral of e to the u, okay. Then we've still got this cos x there that was there before. And then in replace of the dx, I'm going to write du on cos x. Okay, so in replace of the dx. Now, in that case, the cos x's can just disappear, and what I'm left with is the integral of e to the u du. Now, we had to change that to have a du, okay, because we want to integrate it with respect to u. So when we integrate e to the u, really easily, it just becomes e to the u plus a constant, of course, okay? When we integrate the exponential function, it stays as it is. So we get that, and then we just go, well, that is e to the u, and u was sine x plus c. And that's the end of part A. Okay, part B, however. In part B, it says, given that f double prime is equal to 2 sine 2x. What it wants to find is f. So to get from f double prime, or f prime prime, however you want to say it, you need to integrate. So f prime x, okay, is going to be the integral of 2 sine 2x dx. We need to integrate that. When we integrate that, the integral of sine becomes negative cos. So it's going to be negative cos 2x, and we've got to divide by the derivative of this inside bit, the 2x, the derivative of that is 2. When we divide by 2, it would cancel with the 2 that was already there. Okay, so that's nice and easy. Don't forget your constant of integration. So we have that. Now, what we were given in the question was this little key here, and that's what we're going to use now, okay? So what we know is that it equals 0 when we sub in pi on 2 into the first derivative, f prime. So that's 2 times pi on 2 plus c. Okay, so clearly this bit here is just going to go down to pi. Okay, we can take the negative cos pi onto the other side, so it becomes cos of pi equals c. Now, cos of pi, hopefully you know, is -1. So c is equal to -1. So what we've got there is that f prime x equals minus cos 2x minus 1. Okay, so now let's change colours again. F of x is going to equal the integral of that, negative cos 2x minus 1 dx. We should put a dx on there as well. Okay, so we integrate again. When we integrate cos, we get sine. So that's going to be negative sine 2x. And then we've got to divide by the derivative of the inside. So this time we are going to divide by the 2 because there's no 2 there to cancel with. Okay, so we get -1/2. When we integrate the -1, we get minus x. And then we need to add a constant. I'm not going to use c because I've already used c. I'm going to use a different letter. I've chosen k. Choose whatever you like. Okay, so that's what f of x looks like so far. What we know about f of x is this little bit of information here, is that f of 0 equals 3. So let's use it. Okay, it equals 3 when we sub in 0. Well, that's negative a half of sine of 2 times 0. I'm just going to write 0. X is 0 minus 0 plus k. So that tells me that k is equal to sine of 0. That goes to 0 minus 0. So k is equal to 3. So what I know is that f of x is equal to negative a half sine 2x minus x plus 3. Okay? That's not what the question asked for. The question asked for f of pi on 2. We're very nearly home. Okay? Therefore, f of pi on 2 is equal to negative a half sine, sub in pi on 2 now, so it's 2 lots of pi on 2, so hopefully you can see that's just pi, minus, that says minus x, so that's minus pi, and then plus 3. Okay, so sine of pi is 0, so it's just the 3 and the minus pi. That's all we have left. Oh, I've made a mistake because x wasn't pi, x was pi on 2. Okay, so that's 3 minus pi on 2 is our final answer for what is f of pi on 2. Okay.